Hello everyone, this is part 2 of Conic sections. If you didn't check out part 1 dealt with parabolas, and this one that we're going to do now is going to talk about how to slice a cone so you get a circle and slice the cones a little bit of an angle to get an ellipse. Alright, so we're going to show again the HK form of each one of these. We'll start with the circles. That's pretty much going to be the easiest of all the conic sections. So we'll take a look here. We have, again, our HK form, x minus h squared, y minus k squared. The only two things we're going to do is find the center and the radius. So here's our first example, and again, my Pre-Calc class has their note sheet that they're going to work with. For those of you that are not in my Pre-Calc class, thanks for tuning in. Just check out the examples that we got right here with a scrap sheet of paper. We got x plus 2 squared, y minus 3 squared. So again, we know we're going to think opposite right here. So our vertex, x still going with h, y still going with k. We know we're going to have a negative 2, 3 as our center. The last number, r squared, represents the radius squared. So not about 90% of the time, 95% of the time, we're going to get a nice perfect square right here. So we know the square root of 16 means our radius is 4. So what we do from the center is we're going to come up, down, left, and right 4 and make our marks, and then we draw the best circle we can right here. And that's it for our circles. That's all we're going to do for making our circle for HK form. And again, like we talked about in the parabola video, we're going to stick with HK form. We're not going to go beyond that. We're just always going to have it already in that form. Let's look at just one more example here for circles. So we have x minus 4 squared, y plus 3 squared. So again, this is our h, and this is our k. Again, thinking opposite, x minus 4, we got positive 4, y plus 3, we're going to know we're going to be minus 3, so 4, negative 3. We know that r squared right here is equal to 9, so the square root of 9 we know is 3. So from the center, we'll go up, down, left, and right 3, and we'll draw our circle from there. So again, pretty straightforward. Only a couple things we do here for circles. All right. So find HK represents the center. Take the square root of the last number. And again, if the square root is not a perfect square, use your calculator real quick and just go as close as you can to whatever number it is, and then draw your circle. So now let's look at ellipses. There's a little bit more that we do with ellipses. Okay. So as you can see, it looks very similar to our circle, but now we're dividing by some numbers. Okay. So this is a horizontal ellipse, so I'll show you why we know that here in a second. We're going to start with the same thing. Find HK. Every conic we do finds HK. So there's our H, there's our K. So we know that we have 1, 2 is going to be our center of this ellipse. Now, length of the major and minor axis. So how do we do that? Well, what we do is we check, all right, whatever's underneath the X, that's how we know to go left and right, because the x-axis goes left and right. So a squared is represented here by 4. So that means a, if a squared is equal to 4, that means if we take the square root, a has got to be 2. That means from the center, we're going to go to the right 2, and we're going to go to the left 2 and make our mark. So that makes our mark. So that tells us the length of the major axis is 2 times a. We just figured out a was 2. So the length of the major axis here is 4. Now you can either just do 2 times 2, or you can count from this point to this point, and you'll see that we have 4. The number that's underneath the y will tell us how far to go up and down. So knowing that b squared is equal to 1, well, square root of 1 is 1. So we need to go up and down from the center 1 and 1. And that gives us those points. We are going to use these 4 now to draw our ellipse. And that gives us that with a length of the minor axis of 2 times 1 being 2. Or you can just count from there to there. Now, the only thing you will have to do with your calculator now is find this C value, because that C value is going to help us find our focal points. So C value is a squared minus b squared. So a squared minus b squared, that's going to be 4 minus 1, that's 3. So that c squared is going to be 3. Therefore, c is the square root of 3. And you'll need your calculator to the tens place to help us with that. So c is going to be 1.7. We're going to use this 1.7 now to plug it in for our focal points. And there are 2 of these. There's always going to be 2. All right, and they're going to be inside as well. So h plus and minus c comma k. So h again was 1. So we're going to have 1 plus and minus 1.7 comma k, which was 2. So 1 plus 1.7, you got 2.7. 1 minus 1.7, you got 0.7, negative 0.7. So we go ahead and graph these from the origin, and as you're going to see, they're right there at negative 0.72 and 2.72, and that puts us right here on the inside. Your focal points, again, will always be on the major axis as well. Eccentricity is one of those other things that's extra that we're going to do. You just take the c value that's already as a radical and put that over a. All right, so that's going to be radical 3 over 2. We don't really do too much with it. To get a little bit more technical with it, the eccentricity tells us how close we are for this ellipse that's going to be a circle, depending upon what this number does. But all we're going to do in my class right now is just find the value as radical 3 over 2. Now, we knew this one was a horizontal ellipse because the bigger number was underneath the x. If the bigger number is underneath the y, that means we'll go up and down more, which will make this ellipse more vertical, which we'll see in the next example. Notice here that the bigger number is under the y. So a squared is always going to be the bigger of the 2 numbers. So we'll start again by finding our vertex here. There's our h, there's our k, and we know it's going to be 3 and negative 2 because we're thinking opposite again. So we plot 3, negative 2. All right, so remember, whatever's underneath the x, that's what we move left and right. Whatever's underneath the y, that's what we move up and down. Okay, so 3 left and right. So 1, 2, 3, make a mark. 1, 2, 3, make a mark. Up and down 4. So 1, 2, 3, 4, make a mark. Down 4, make a mark. And that's how we know that the length of the major axis, again, knowing that a squared is equal to 16, a's got to be 4. B squared is equal to 9, therefore B has got to be 3. All right, so that's how far we move up and down, left and right, and length of the major axis, 2 times 4. That's 8, or again, you can count from this endpoint to this endpoint, and you see 8, this endpoint to this endpoint. We make our ellipse. Okay. Now, find our focal point. So we need that c value, a squared minus b squared. Now remember, a squared is the bigger of the 2. All right, so you have to take 16 minus 9 on your calculator. So that means c squared is equal to 7, and then c is equal to the square root of 7, which is going to come out to about 2.6. We're going to use 2.6 to help us with our focal points. Notice the formula changes from the previous one. Now it's h, comma, k, negative 2, plus or minus 2.6. All right, so now plugging those in, we're going to get 2 focal points of 3, 0.6 and 3, negative 4.6. They are inside and they are on the major axis. And again, these are plotted from the origin. We go 3 and then 0.6 and then 3, negative 4.6. Our eccentricity, we keep it in radical form as radical 7 over a. Remembering again, a was the bigger of the 2, so a was going to be 4. So radical 7 over 4. So there were 2 quick examples of circles and ellipses. That's part 2 of our conic section unit here in Pre-Calc. Part 1 was parabolas. Hopefully you checked that one out before you did this one. And then coming up next, part 3 will be the hyperbolas. Thanks for tuning in, guys.